DNS exam number 2, problem number 26. In this problem, they gave you some information about a function, and then they asked you to come up with the equation of a normal line to a curve. And that might throw people a little bit. Those of you who've taken physics might remember what this is a little bit. A normal line is simply a line that is perpendicular to a tangent line, but drawn to that same point of tangency. So to find the slope of a tangent, the slope of a normal, we start off by finding the slope of a tangent. So what's going on right here? This is the function we were given. Y was equal to, and since I knew we were going to do a derivative, I went ahead and rewrote a cube root as something to the 1/3 power. They wanted us to deal with the spot where x was equal to 3. So I thought now would be a good time to go ahead and plug that 3 in there, and found that y of 3, well, the 3 squared was 9, minus 1 was 8, and the cube root of 8 was going to be 2. So that meant that our point of tangency right here is the ordered pair 3, 2. But, as we'll see here in a second, the point of tangency is really the same thing as your point of normalcy, if you want to look at it that way as well. So we know the function, we know the point that we're dealing with. Let's go ahead and find the derivative now in order to find the slope of that tangent. So y prime was going to be, using the power rule now, 1/3 comes out in front, the base stays the same. We drop the exponent by 1 to a negative 2/3, and don't forget the chain rule. Times the derivative within, that x squared minus 1 is going to give us a derivative of 2x. Cleaning all that up just a little bit, there's a 2x up on the top, the 1/3 puts a 3 on the bottom, and a negative 2/3 power becomes a cube root of the x squared minus 1 squared down in the denominator. A little bit messy, but that was y prime. So now we were going to go ahead and evaluate y prime at the point in question of 3, 2. So plugging a 3 in here for the x, the 2 times 3 is going to give us a 6 on top. Down on the bottom, I kept the 3 there for now. We did this work before. The 3 squared minus 1 is going to be an 8. Now remember, you could either do 8 squared to get 64 and then take the cube root of that, or you could have done it the other way, done the cube root of 8 and then squared that result. Either way you're going to do it, you're going to end up with 4 for that result there, times the 3 is going to give you a 12 down on the bottom. The 6 over 12 means that the 1/2 is what we got for y prime of 3, and y prime is going to get you the slope of your tangent. Now the normal that we know has to be perpendicular to the tangent. So if the slope of our tangent was 1/2, we were able to conclude then that the slope of our normal was going to have to be the opposite reciprocal of the slope of that tangent, so that was going to be negative 2. So now at this point, we know the two important things we need to know about our normal. We know the slope of that normal right here is negative 2, and we know that the point of tangency or the point of normalcy, however you want to look at it, is the ordered pair 3, 2. So knowing a point and knowing the slope of our normal line in question, we're going to go to point slope form. Y minus your y coordinate gives you a y minus 2 equals the slope of this line is going to be a negative 2, that went right here, and then x minus your x coordinate is going to give you an x minus 3. So that's the equation right there in point slope form. Given that this was a multiple choice question though, it wasn't up to us what form to leave it in, although if it was free response, you could have just quit right there. So I went ahead and solved that thing for y, distributed the negative 2, added the 2 over, and got y equals negative 2x plus 8, and then realized that none of the 4 choices were in that form. They were all in something a little bit odd, but luckily the only one that had an 8 in it was D, which was written as y is equal to, or y plus 2x is equal to 8. So that was the answer there, D.